Hi everybody, this is Dr. Merrill. Hey, I'm just giving you this video because I realized that I forgot to record the meeting tonight and just wanted to make sure that you had an idea of what we went over. Um, so starting out, this week is all about evaluating claims. We're going to look at the paper that talked about the connection between autism and vaccines, as well as kind of get you guys prepped for where to find sources for the upcoming group activities and things like that. Okay. So first off, when you guys get started, this is the prompt for the lesson 3 activities, telling you, kind of the steps on how you should start to evaluate these scientific claims, that kind of thing. So the big one that you're going to need is for the group discussion board. This is in the, let me just pop over to this page really quick. Let's pick the right one. This is over in the lesson 3, the explore and the group discussion. This is where you're going to find the link to the article as well as some review articles about it. This is primary research, so it's a little dense. I'll show you this in just a second. It's also a little tough to read for another couple of reasons. So you may want to start with this one, but you do need to take some time and look through this article right there. And as you read it, think about these things, how can you present a claim, how can you validate, that kind of thing. Because in this day and age, it's so easy to hear something on the news or to hear your friends say, oh, I heard that, or whatever. And a lot of people take these claims at face value. And one of the most important things about this class and just about, attending college in general is learning how to educate yourself about issues and making your own decisions. So hopefully this will get you started. Okay. I want to spend the bulk of it looking at the article. There's a couple of questions in the quiz that you need to think about. So let's go ahead and get started. So first off, this is the article. This is actually, in fact, I'm going to pop over into a different view. This is, I just pulled up the PDF. Okay, this is the paper that was published that the whole vaccines cause autism issue arose from. This was from a group out of Britain. It was published in a journal called The Lancet. It's a very big medical journal in England. It's a very reputable source. The short answer is that these researchers did this study looking at vaccines causing some gastrointestinal issues and some neurological issues, and they were the ones that said, hey, these are, vaccines are causing this autism, and it was later shown to be wrong, that they falsified the data. It turns out that this group, they were being paid by a group of lawyers that were representing some patients who thought that their children had gotten autism from vaccines. So there was some major conflict of interest and some other things like that. But I just want to point out a couple of things about this article. Okay, when you actually search the article and you download the PDF, I did not add this. This comes with the article. Every single version of this article that you find will have this big retracted watermark across it to let everybody know that it's been retracted. Just so you guys know, when you find things like this is a bad sign, right? If something has to be retracted this badly, it's a big deal, and everything in it you should completely disregard because it's been shown to be incorrect for several reasons. Okay, as you read through this paper, I know that this is primary research, so there's a lot of things in here that you may not understand, a lot of terminology and things like that. But there are still some things that you should be able to look at and kind of think about and go, maybe that's not quite right. And I'm just gonna highlight a few things as you to kind of keep in mind. Okay, first off, okay, there's a couple of things right off the bat that kind of strike you as a little weird about this. Okay, first off, the title, right? Ileum and colitis, right? These are both gastrointestinal issues. This is a part of the intestine. This is a particular disease of the large intestine. Okay, so they're talking mostly about GI disorders. If you scroll down to the bottom, you can see, for example, that this group, they're part of maybe it's not going to let me highlight it. There we go. Whoops. They're part of this. Whoops, come on, you. This group, okay, I'm just gonna point out it right here. They're part of this inflammatory bowel disease study group, okay. Gastroenterology, they're in pediatric gastroenterology, you know, things like that. So the fact that they are reporting on this neurological disorder is a little strange, okay. Sometimes research will take you into new and unexpected places, but you know, when you're talking about things, you know, that happen in the gut and in the brain, and you're not talking about stress, it's a little weird. So there's you know, a couple of things right off the bat that make you go, that maybe might be a little funny. Okay. Another thing, I'm going to show you this right here. That was their sample size, 12 kids. That's it. Okay. I realize that you guys don't do research, but a sample size of 12 for a human trial is very, very low. Most human trials, or most studies involving human patients, need to be in the dozens to hundreds range as far as the number of subjects. So the fact that this has 12 people in it, that's a little weird, okay? If you're doing studies in an experimental model that involve like rodents or zebrafish or Drosophila, which is a fruit fly, or things like that, where everything is carefully controlled, you can use smaller sample sizes like 12 or 15, things like that, because you can literally control everything about the experiment so that the only change is the one that you give, okay? To have it be only a 12-person sample in a human trial is unheard of, okay? There is simply no way to control all of the different variables that can happen that could be affecting the study. So that's a big red flag right off the bat that the sample size is so small. Okay, so there's a couple other things. As you scroll down, okay, here's the other thing that is very, very, very strange. Okay, in their results, okay, when you start looking at this, this is all their GI results. If you scroll down to the next page, these are all of the neurological problems that came with this supposed vaccine, okay? And you notice autism, 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 autism. Almost all of these kids supposedly display autism. So out of 12 kids, there are 1, 2, 3, and they're calling these question marks, that are showing something other than autism, okay? That's 75% of their sample size is coming up with this particular this particular effect. Okay, again, because you guys don't know research, you probably won't realize this, but in a human trial, if you can show a 20 to 30% effect, you're doing really, really well. Okay, in human trials, it's very, very difficult to show a big effect. So anything over about 30% is really questionable. And you really have to do your due diligence to show that this is actually happening, okay? So the fact that they're showing 75% occurrence of this disease is really, really out there, okay? Again, if you go back to a carefully controlled trial where you're using rodents or zebrafish or something where all of the animals are housed the same way, they're fed the same way, they're watered out of the same water source, the lights go on and off at the same time, stuff like that, you can get 75% and sometimes even higher effect. But in a human trial, 75%, it's absolutely unheard of, okay? So that's those are just a couple of things as you read through the paper that you can think about and go, okay, that's maybe a little weird, okay? So you can think about that, okay? A couple of other things. Sometimes in science, weird things happen, right? Sometimes when we do these studies, you can get results that are not, that really don't fit well with what everybody else has published. And a good scientist will bring these up, and they will say things like, you know, we got this result and it doesn't fit in with these other results which say this, this, and this. and this may be why, and we need to test it more. They openly acknowledge that something is weird, and they keep looking. Okay, these guys in this paper, there's a statement that they make in the beginning of the discussion. It says something about, and I'm going to highlight it for you. Okay, they talk about these pathologies reflecting a selection bias in a self-referred group. Okay, human studies are tough. They often do these. Okay, but from here on out, they completely sweep it under the rug. That's it. They don't mention it anymore. And they don't make any, and they immediately go to say that the uniformity of all of these other things reflects that it's, it's the truth. Well, again, they've acknowledged this bias. They've acknowledged that there may potentially be something wrong with their study, and then they completely sweep it under the rug. That's not okay. Okay? This is the type of thing that raises red flags all over the place. Okay? So, they kind of tried to acknowledge that maybe something was a little weird, and then they just completely ignored it. Usually that's a really, really bad sign. Okay, this is a very, very good example of what not to do in science. Okay, and again, like I told you, it came out that that this paper had to be retracted. It came out that the investigators were doing things, they were falsifying data, they were making stuff up. Come to find out that they were being paid by this legal firm that were representing these supposed autism patients, which is a huge conflict of interest. So this is a kind of a big deal. Just keep that in mind as you read stuff. So with that in mind, I'm going to come back over here. Okay, and again, really quick, so this is the thing that led to the entire autism versus vaccination thing. In numerous studies since, it's been shown that this is not the case. Okay, so one of the problems and one of the things in science is that when we do these studies, especially if it's something that's supposedly groundbreaking, that's going to change the landscape, several other groups will verify that this is actually the case. And in this particular instance, all these other labs, when this paper was published, all these other labs started looking, and nobody found anything. Nobody could reproduce their results, which led them to find out that it was all fake and that they'd falsified the data. Okay, so this is a really good example of how science is not supposed to work. So you may be asking yourself at this point, how do I go about investigating these? If I'm supposed to be able to look at these and find out, okay, how am I supposed to investigate these approaches? Okay, and that leads us to where can you get more information? And this is particularly important for the for this upcoming assignment. I'm going to pause the video right here, so go ahead and continue this in the next one, and we will see you in just a minute.